Hi guys, so in class we talked about voltage and here are the very small demo I did. So I have a voltmeter. So here you have a battery and it's called the long-term battery and it's the voltage is 6 volts. So this is the positive electrode, that's the negative electrode. That means if I make a circuit with a lamp, that's going to be for a lamp, a lantern, each coulomb of charge here leaving the positive electrode will carry 6 joule. Okay, so each coulomb of charge has 6 joule of energy or potential energy relative to the negative electrode. Actually, this is not really what's happening because it's not positive charge positive charges flowing from plus to minus, even though it's the conventional current go from plus to minus, but it's actually electrons. So each electron will carry 6 electron volt of energy. Electron volt is a unit of energy relative to the positive electron. So anyway, 6 volts is not that much, but you see it's heavy and it's big. That's because it's able to produce a lot of current. And remember, energy per unit second of power is voltage times current. So even though the voltage is not that much, the current will be large because to power a lamp or light bulb, you need a lot of current. So it's not so much about the voltage, it's about the current, right? So I can show you that with my voltmeter here. And you see that I have about 5.99 volt. Okay, so I still have a lot of joules. Here you have a battery, it's 1.5 volt, 1.5 volt, but you see it's smaller than these batteries here, which are AA. That's because even though it has the same voltage as a AA battery, it's bigger, you have more chemical reaction going on, so it will produce more current. So you see here, that will be the positive electrode, that's going to be the negative electrode. And if I measure the voltage here, I have about 1.53 volt. Okay, so those dollar stores battery that you buy, even though it says 1.5 volt, they are not going to boost a lot of current, right? So they will you will have to throw them very quickly. So here I have 4 batteries in series. Each of them is 1.5 volt, and you see how the plus is connected to the minus is connected to the plus, then the minus to the plus, and the minus to the plus. So in series, that means 1.5, 1.5, 1.5, 1.5, it's going to be about 6 volt. And you see here you have a positive wire, okay, connected to the positive electrode. So it's a series, a circuit in series. And if I measure how much I have, I hope you can see here, it says 5.7 volt, right? So it means it has lost some of the voltage. If you have 2 batteries in series, so here you have 1.5 and 1.5, and you should have 3 volt. About 3.1 volt, okay? You also have the tiny one, the AAA. That means it's going to be the same voltage, but not the same current. So here I have batteries in series. You use that for an airsoft gun. So each one of them, it says 1.2. And they connect them in series. So you have 1, 2, 3, 4, 5, 6, 7, 8. So 8 times 1.2, it says here 9.6 volt, and it's a you can recharge the battery. Okay, and if I do it right, it has been used. So I don't know if I have that much voltage, but you see again you have red and black, so I'm going to stick my probes here, and you have, it says 6.75 volt, so it's not the 9.6 that they claim. That means some it's used. I will need to recharge them to get to the 9.6 volt. Okay, these are cheap batteries, I think. And here is another example of a power source. It's a solar panel, a mini one, right? I think I can remove the plastic here. Okay, so those cells here are in series. So each one of them is 0.5. So 0.5, 0.5, 0.5, 0.5. I have a 2 volt solar cell, and it's polarized. So one will be positive, the other one will be negative. So of course it depends on the light. So here I have light, but not that much. Let's see how much we read. It says about 1 volt. Okay, so I don't get the 2 volt. If I want to get the 2 volt, I need to get closer to the light. I don't know if you can see here, I'm getting closer. So now I have 118, closer to closer, 1.48, and if I keep going, I can get to 2. Okay. By the way, you can even check the inverse square law. If you multiply the distance by 2 from the light source, you get 4 times less photons. So those photons here kick out electrons from semiconductor material. I have another one here. It's a cheap one. It never worked, but it's supposed to give you 5 volt. So if you do the computation, each cell is 0.5, you multiply by the number of cells, in theory you should get 5 volt. It never worked properly, nevertheless, so I use it for a demo. I was supposed to charge a phone, but it didn't work. But you can see here, I hope you can see the voltmeter. You see I have about 2 volt, 2.4, 2.6, 2.8, and you can increase up to 5 volt. Okay, but it never produced, it's a chip. Never worked properly. Okay, so the last thing I wanted to show you is that if you want to have a cheap power supply, you can hack those guys here. You see here, you can change the voltage. Maximum is 12 volt, so you can have 3 volt, 4.5, 6, 7.5, 9, and 12. So you can change here, and what you can do here is split. You can split the two ends. Here you can have alligator clip, and like this you have your own DC power supply, very cheap. Maximum current is 1 amp. So that means there is some kind of fuse inside that will open, and that will break the circuit if you go over 1 amp. So it's convenient. Like this, it's safe. Okay. All you have to do is to put sandpaper to cut the end, and you have your power supply. Another thing I did in class, but I'm not going to do it here. I can, so you don't do it. You can go to AC voltage here. So you see here it says AC. Go to 200 voltage AC, and I put that in a wall plug, okay, outlet, and this one will be in the hot hole, and this one will be in the return hole. Then you will read about 120 volt AC, which is kind of an average, so it will be a sine wave with some kind of average of 120 volt AC. Okay, so that's all I did in class.